Hey guys, welcome to lesson 2 of Precalculus. I know that you guys probably see this and say, what is that? I have another problem underneath that, so I'm going to first start with a simple problem. I'm going to give you guys this parabola, y equals x squared minus 2x minus 3, and I'm going to have you guys answer a few questions, or I'm going to basically answer them. But if you would like to put it on pause and answer it yourself and see if you're correct, that would be great. The first question is, find the x-intercept, if there are any, algebraically. So once again, this is a parabola, and we know from algebra, geometry, algebra 2 trig, that parabolas open up like this, concaved up, or concave down. Okay? So how are we going to find the x-intercepts? Well, we learned in the last video that if we wanted to find the x-intercept, we just substitute 0 into the y, and then we solve. Well, anytime we're solving parabolas, we're either going to, anytime we're solving quadratic equations, we're either going to factor or use the quadratic equation. You can also complete the square, but I'm just going to factor in this case. X times x will give you the beginning. What gives us the sign negative, positive and a negative, and it doesn't matter where it goes yet. And then what gives us a 3 that will subtract to a negative 2? Well, a negative 3 and a positive 1. You should always check to make sure that it gives you the middle. Here's the outside, and here's the inside. You don't have to check the front and the back because we already decided that what gives us x squared is x and x, and what gives us the back is this and this. So you just have to check what I call a double smiley face, okay? So with that being said, let's see what we have here. Okay. So we said plus 1x, that gives you a negative 2x, that gives you the middle, that's great. Let's take each piece and set it equal to 0, and those are your two x-intercepts, okay? What about the next part of this? It says find the turning point algebraically. Well, in order to find the turning point of a parabola, you can use the equation x equals negative b over 2a. Remind yourself that a is the number that is in front of the x squared, so in this case it's 1. B is in the number that's in front of the x, so that's negative 2, and C is the number in front of or after the x, that's negative 3. So in this case, we're going to say negative b, so it's a negative 2 over 2 times 1. So it's just going to be 2 over 1, which is 1, okay? But because I'm asking you for a point, you're going to have to put this back in to the equation. That's how we get the y part. So I'm running out of room. I'm probably going to go down to the next page. We're going to say y equals x squared minus 2x minus 3 has x-intercepts at x equals and x equals, we said negative 1 and positive 3. We said that there's a turning point. We're going to substitute the value that we found, which is 1, based off of this formula, into, so we get 1 minus 2 minus 3, and we're basically going to get negative 4. So the point, the turning point is 1 comma negative 4. Now, I'm just going to quickly graph those points. We know x-intercepts means the y value is 0, okay? And turning at 1, negative 4. I need to figure out where the y-intercept is because I can't just go like this. I can't just make it connect. You gotta figure that part out. But what I want you to see before I start connecting all this stuff is the following. We have our x-intercept here and here, and the turning point right there. I wrote, what do you notice about the x-intercept and the turning point? Well, if you think about it for a second, 1, 2, 3, 4 units. And now from this point to this point, from this x-intercept to this x-intercept, and the turning point is literally halfway. So if you take these two and average it, you'll get the turning point, -1 plus 3, but average it. So that's going to be 1. So that's a way that we can find the turning point, okay? So everybody should see that. And let's continue. The next part says find the y-intercept, if any. So let's find the y-intercept. Remember, you guys can pause this. Find the y-intercept by setting x equal to 0. This is 0, that's 0, you're left with -3. So the y-intercept is -3, and that makes sense because it's going to have to pass somewhere. We need to know where it's going to pass. It makes sense to pass. Okay? So the reason why I know it opens this way is because when the number that's in front of the x squared is a positive, it opens up. We say it's concaved up. I wrote, does a parabola never, sometimes, or always have a y-intercept? You should press the pause button and think about it for a second. Does a parabola never, sometimes, or always have a y-intercept? It always has a y-intercept. Parabolas, try to draw it without cutting. Some of you might say, well, that doesn't. Well, it does actually. We put arrows and we're stopping it, but if you kept going, parabola doesn't stop. It's continuous. We call it a continuous function. It's continuous, and it will eventually cut that. But what you notice here, guys, is that this did not pass through the x-axis. So even though it must have a y-intercept, does a parabola sometimes, never, or always have a y-intercept? Always. And even though it does a parabola never, sometimes, or always have an x-intercept? Sometimes it does, like in the example we just did here, and sometimes it doesn't, like the example we just did there. Finally, I wrote the domain of a parabola, of any parabola, is -infinity to +infinity. Explain why that's true. Well, the domain basically says, what x value can I not put in there? Or what x value can I put in where I can get back a y? All right? And for parabolas, such as this, nothing will ever mess up. You could put 0.5, 0.7, you'll always get a y answer. So a parabola is continuous, and so any x works. But what is the range, or write the range in the interval notation? Okay. Here's our graph, everyone. Let me get rid of this. The range is the y. What's the lowest y point this goes to? Well, this range is going to be, pardon me, this point, this turning point, we said was 1, -4, which is x, y. Everything goes up, and nothing ever goes below -4. So my range is that, or in interval notation, it's from -4 and up. Up means +infinity. I didn't ask this question, but I will right now. My final question is, what is the axis of symmetry? The axis of symmetry is basically a vertical line that will slice the parabola in half. Well, guess what, guys? It's right there. And that's this part. So this part is the axis of symmetry. And I'm going to say it in a certain weird way. Axis of symmetry. Axis of symmetry. Okay? And this will always be our range. But you have to decide, is it going to go from -4 and up or -4 and down? Well, it depends on which way it's open. So I hope this video was great. Come back for another video. Have a great day.